Hi everyone, it's Matt. In this little project I will show you how to build a little control box like this. This will allow you to monitor the usage of 220 volts supply, in this case a bench power supply. Through a Rfid module, this control box will turn on and off this 220 volts appliance. You can hardwire it into television, a console, to a personal computer if you have a shared one, to whatever you like. It's not that hard to build, although it put together different modules. So let's see which component we will use. In order to identify the user, I'm going to use an RFID module with some personal tags. You can find it on eBay for about 4 to 5 euros. The S3231 module for keeping track of the time with its battery, CR2032. You can find it on eBay for about 2 euros. All information will be shown on this LCD display, a 4 lines blue one, which also you can find for about 5 euros. A single channel relay for doing the actual turning on and off thing. A 9 volts power supply, an old transformer. It must be from 5 to 12 volts and must supply at least 500 milliamps of current. This will work just fine. If you don't have one lying around, you can buy it for about 4 euros. A white plastic project box for keeping everything as tidy as possible. This also will come for about 4 euros. And almost obviously, everything will be coordinated via an Arduino Uno. I will also use the 1 kilobyte eeprom onboard space for storing the user's data. More on that later. For storing this data, I could use an SD shield, but I've decided to keep things as minimal as possible, so I will use the eeprom memory. An Arduino Uno compatible board will cost you about 7 euros. So I've just hooked everything up according to these schematics. The RFID module goes here and is connected to the Arduino through SPI interface. It takes 1, 2, 3, 4 digital pin plus 3.3 volts. Here goes the DS3231 module, which uses I2C interface, so the analog pin A4 and A5. It's also powered by the 3.3 line. Up here we have the 5 volts line. The relay module uses 5 volts and is connected to digital pin D10. And the LCD display uses 5 volts too. For more details, you should look to a liquid crystal tutorial on the Arduino site. But basically, here we have a potentiometer for adjusting the contrast, and this resistance here commands the backlight. And this LCD screen uses 6 digital pin, or 5 digital pin plus 1 analog pin in my case, but you can reroute this line here onto the last, I think, yes, the sixth digital pin, which is the last remaining. It's a little bit chaotic, but if you proceed step by step, adding one module after another, you should have no problem. So first thing, I power everything up, and I will upload this first sketch. This sketch will print on the eeprom all these users information according to this sort of structure. The first byte will contain a number of users, from byte 1 to 12 the name of the user, and so on. So I will go on and upload this, and well, nothing will happen because we will just write some information on the eeprom memory. I have uploaded 2 users, I think. Yes, 1 and 2. Then this is the main sketch. I will upload it and just test it. Uploading. Right, and if I open the serial monitor, I will see that I have imported correctly 2 users, 1 and 2, the name, the ID, the time in seconds which a single user can use in a month, the time remaining. So for instance, the first user has 90 seconds a month. Of course, this is a test, and just 80 seconds remaining. The last login month. Oh, for God's sakes! Last login month. In the case of the first user, is the month 2, so February. In the case of the second user, is the 11th month, and so. And this is the ID of the tag. So, for instance, if I take the tag and slide it, as you can see, I am greeted. Welcome, Matteo, which is my name. And the time will start counting back to 0. Here, just to set the contrast right for the camera. Right, if I slide the same card back again, the relay will turn off, click, and the time will stop. If I again slide it, the card, I will start again from when I've left, so 57 and back. And of course, this will be written onto the eeprom memory. So if I unplug it completely and I power on again, I will just starting back from where I've left. So in this case, 39 seconds. Since everything works fine, let's put all the components in a proper case. I've swapped the original Arduino Uno for a copy, so I could solder the connectors of the Rfid module, the time module, the power line, and also the relay module right into the board. Just the LCD screen will be connected via pins. I've mounted the Rfid module up top, so it's convenient enough for sliding the badge, while I've left the serial connector visible to the right side of the case for upload further code. Anyway, the connections are the same as before. I've just soldered what I could for convenience. I have decided to plug this device to this power supply. It was an old desktop PSU, which I've converted to a bench power supply. I just need to hijack the power line, the main line, to the relay. And now when I slide the badge, the relay will close and will turn on the power supply. When the timer runs out or I slide back, the PSU will turn itself off. For this example, I have connected to 12 volts and to the ground these 4 LED lamps with its little cooling fan. So I turn this on with the main switch, and when I slide my card, I'm greeted and the LED lamp turns itself on. Here we can barely see the seconds counting back. And if I slide the card again, the lamp turns itself off. And so there we have it. Whoop. Apparently this card already ran up of time, so for this month I cannot use this card to turn the power supply on anymore. I will need another tag, which hopefully is full. Yes, this one I've left 120 seconds, so maybe it's not wise to waste it. Anyway, this is just a test, of course, but this is it. I hope you appreciate it. A fun project which put together some very useful modules which can be used separately for other projects. That's it. See you next time.